functions, and then that's what we watch. So now we need to start the actual calculus. So basically we'll be doing derivatives, right? So calculus comprises of two main aspects. That's how do you call it? Differentiation and differentiation and integration. So these are the two main concepts inside calculus. And I see that there is practical without optimization. That's mostly from differentiation side. So we'll be doing a lot of optimization. So that's a lot of practical concepts. So we'll be starting with differentiation, and then later it's going to be integration. But before you even go to integration, you need to go and do the concave and converse functions. So yeah, so differentiation will be where we'll be spending a lot of time on, and then if that one is solid, moving forward will be easier and faster. All right. So we are starting with differentiation. So for every function, we are going to start with so if you take a function, let me just go over that. Yeah, I've started recording. If you take a function, we have 2x minus 4. Another way of, instead of writing this twin could be written as y is equal to 2x minus 4. But so this is another writing of it, another way of writing it. But this is very basic, too basic. Okay, so another way of writing the f of x is this one, right? But I'll mostly be using this function. All right. So and I explained that a function is just a mathematical tool, a mathematical calculator or machine where you put in something and then to give you an output. An example is just a calculator. So when you have a calculator, you punch in some values, and then on the right, with the right, it will do the right operations, and then give you an output. That output is what we call what we have as the f of x or the y. That's the output. And then what you put inside is what we have here. That's what we have inside the bracket, and that is what is defined in the full expression of the function. So this one is like the variable or the label of the function, and then how that function is described is what is written over here, 2x minus 4. It means that whenever you put anything x inside, that particular thing, that value that you put inside, it will go through this particular operation and give you an output. That final output will be your f of x or your y, basically, right? So this one that is inside the bracket, we call it the independent variable. So s is the independent variable, meaning that s is not depending on anything within the function. It's independent variable. So they are all variables. So y is also a variable, but that's a dependent variable because it's going to depend on the value that x will be. So you see that y is equal to 2x minus 4. When s is equal to 1, you realize that will be 2 minus 4, which will be negative 2. Then that's why we say that, okay, before you can get the value of y, we need to know x before proceeding. So in that matter, we call it the dependent variable. So this is a dependent variable. It's depending on the independent variable x. All right. So that's just basic introduction of functions again. But now we are going to do something called calculus, like there is differentiation. So if you are differentiating a function, all right. So differentiation basically means like difference, right? So I'm going to write y is equal to 2x minus 4. So what we are looking at differentiation is that we are trying to see, okay, so we know that dependent variable will be there, independent variable will also be, independent variable will come in, and then based on that value, it will give us something y. But then we want to actually have an idea of if the rate at which, if the independent, let's say change in y, so that will be the, so you have something like this triangle. This triangle just means difference or change. The triangle means change or difference. So the change in y over the change in x, it means that how is the y changing based on the rate at which we are also changing the x. So y can be y1 minus y2 over x1 minus x2. So meaning that x is changing from some value to another value. So we know that whenever s changes, y changes. Whenever s changes, y changes. Whenever s changes, y changes, because s is one that is driving the value of y. So then we have to understand, if we are changing based on the rate at which we are changing the x, at what rate will the y also be changing? That's the whole concept of differentiation. So if you are changing the x, how would that be affecting the change in the y? So you find that ratio. So that's the change in x over change in y. So basically find the differential of the function, right? So you find the differential in terms of the dependent variable, the independent variable, sorry, in terms of the variable. So that one, instead of doing this change, you usually write the y over the x. So it's depending over the s. But if we are doing like the s over the y, it means that the rate at which the y is changing, right? When we change the y, what will happen to the x? That's the meaning. So we are differentiating in terms of y. But in this case, for this first one, we are differentiating in terms of the x. The one at the denominator is the one that is driving the change. So that's the focus. All right. So we write dy dx, right? In calculus in most terms. But you can also see this particular written like changing y over changing x, right? They are similar. So we'll look at, when we are doing the applications, we'll see how they are similar and they are not the same sometimes, right? But right now, you said,
I wanted to ask that because I watched a video, they were talking about the Sika line and whatever line.
Oh, all right. We'll get it. I mean, especially the practical side. All right. So now let's start with how to do that differentiation now. So the differentiation approach that you take, there are so many approaches. Actually, there are so many rules for differentiation. Looking at the function, you should be able to know how to do the differentiation depending on the method. So there are so many methods, right? So looking at the function, you need to know what method to use to do a differentiation. But we are going to start very, very small and build up on the differentiation concepts from one function to the next, so that when we are done building all the tools around it, then when I give a function and I say differentiate, then you use the right method or the right function to be able to differentiate for us. All right. So now let's start with a very, very basic one. So let's say we have a term. Let's say ax to the power n, like ax to the power n. We want to do this. We want to differentiate this. So if you differentiate this, what we are actually going to get is that you bring the a will be there. A will be there. That will multiply the power at the top. That will be n. Then we are bringing the x. X is maintained over there. We maintain it. Then whatever the power is, we reduce the power by a unit. And that will give us the answer that we are doing differentiation. For example, if I have 4x squared to differentiate, then that will mean that we need to do that 4, which is the a here, times the power 2, which is coming, x, and the numerator is 2 minus 1. And then that will give us 8x to the power 1. So if it is to the power 1, we don't actually write it, we just write 8x. If it's power 1, we don't write the 1, we just say 8x. So the answer for this differential is just 8x. So you use whatever you have there, then to multiply whatever it is. So if I have to differentiate s cubed, you see that whatever is here is actually 1, but we don't write it. So for that matter, we 1 times 3 multiplying x to the power 3 minus 1. You don't have to go through that 3 minus 1 thing, because I'm teaching it, that's why. So it should have just been 3x squared. Then we have the differential of that particular function. Right, that's if you have only one term. So if you have multiple terms that are separated by plus or minus, if they are separated by plus or minus, then you do the same thing for each term like that separately. You do the same thing for each term like that. So we may have something like 3x squared minus 4x cubed. So this is one term, this is another term. So they are separated by plus or minus. Let me do plus 6x plus 6x plus 7. Let me see, plus 7. And we have to differentiate all this. So what you have to focus on is that you focus on the term one by one and you do differentiation for each of them. So for the first one, when we differentiate this, these two will come down, multiply this, become 6x, because the numerator, which is 2 minus 1, that will be 1, and when it is 1 we don't write it, minus, then 4 times 3, that will be 12, then x to the power 2, because we have to always reduce the numerator by a unit, plus 6 to the power. So here is 1, the power here is 1 times is 6, so it's supposed to be x to the power 1 minus 1, that will be 0, right? Okay, so now we will have this guy. So if you look at this guy, right, initially if you look at this one, you can rewrite this thing as 7x to the power 0, because if the index of any particular number is 0, the whole thing is 1. So any particular number raised to the power 0 is 1. That's why it's written like this, 7, because 7 times 1, let's say x to the power 0 is 1, so 7 times 1 is 7. That's why it's not there. But if you want to do the differentiation, the reason behind this guy is that when you want to do the differentiation, we do the same procedure, but this one will be doing 7 times the power here is 0. 7 times the power here is 0. This will go to x to the power negative 1, but 0 times any number is 0. So that's why when you have a constant and you are differentiating a constant, we just say 0, we ignore it. So it is not going to appear, or normally we should have said plus 0 here, but if it's 0, we don't actually write it. So if you have a constant, that's the reason why it is a 0, because it's x to the power 0 here. If you multiply 7 and 0, you have 0, and then you don't have to even proceed to do anything, worry yourself about that. And
okay,
you said
you finished. I wanted to ask about the notation.
All right, so for this one is 6x to the power 0, and I say that anything to the power 0 is 1. So this case, if it's x to the power 0, is considered 1, so we actually just don't write the variable. We just don't write the variable, but we keep whatever constant that we get over there. So it is 6. Yeah, so you can ask your question.
No, so I was asking the function that f of x, when we differentiate, do we now do it f prime of x?
Yes.
Okay.
Right. Yeah. So we have, I'm just giving general rule of how to do differentiations side by side.
Okay.
Right. So now that we know, we have an idea of how each of them is done, then the notation. So I told you in math there are so many things that mean a lot of things. So today we have seen that this one means change, and then so for f of x is equal to 2x minus, right, or it could be written as y is equal to 2s minus 4. So if you have to differentiate this, right, so if the differential, for us to know that you are doing differential, is going to be f prime of x. So meaning we are doing the first differential of it, we are differentiating it for the first time. That's what f prime of x. So if you differentiate 2x, we are going to have 2. If we differentiate the constant, is 0, so we don't even write it. If not, normally it should be minus 0, but 2 minus 0 is 2, so we keep it as such. So this is a differential. So if it is f of x is what is f prime of x, but if it is this form, y form, is y prime, right? Or you can just do dy over dx. So all those notations are they all mean the same thing. Remember, this case it is d. It is d. There are another case that we will see the d bent small. Dy over dx. The head of the d is bent small. We'll talk about it later on, but right now we are just focusing on this straight ones. So they all mean the same thing. They all mean differential. All right. I guess there's no question. Rajaram, please, can you follow? Are you following, or we have network issue? Are we good? Are we safe so far? I guess network is still beating us.
Hello, Francis. Are you calling me?
Yes, I say, are we good?
Oh, I'm good.
As for customers, yeah, my man is a senior.
Wow, congratulations.
Yeah, he's a senior.
So, good news.
All right.
Not you, sorry.
Sure. So now we have a function here that I want us to find the f prime of it, or the differential, which is 3x to the power 4 minus 2x squared plus 1. So we have to find f prime of x, and then we'll find the second derivative. That's like f prime prime of x. Meaning that when you find the derivative, the first derivative, you do it again for these guys, the result that you get. You find the second derivative and you get the final answer. So let's find the f prime. So you can just mention it, I'll write it.
It's 12x cubed.
All right.
Minus 4x.
All right. So yeah, that's correct. What about the second derivative?
The second derivative is 36x squared minus 4.
Yeah. All right. So that one we are safe. So yep. So this is just basic, very, very basic differentiation that is so straight. All right. But in terms of applications, right? In terms of applications, this is the concept around derivatives. So one way of the application is in terms of distance. For example, when they give us something like, when they give you an expression like that is distance. So for distance, we are going to use s for distance, right? S, a function s of t, right? So it's not f of s or something like that. And I say 3t cubed minus 4t squared plus t, for example. So this is like distance in terms of t. So you see that t is there. It's not always that it's x. So f of s is a general format for you to know how the things are. But t is our s in this case. That's why you can see that the s is written in terms of the s. See, so the t will be the one you found inside the variable. And then in this case, we are having t. So if you differentiate distance, I mean in the application, so this is distance. So this is distance. You know that if you are differentiating this, you usually say it's like changing s over changing t. So you know that it's going to be like displacement, which is d over t. If you do this displacement, so this is giving you like velocity or speed. So you should know that when you differentiate an expression that is in distance, when you differentiate in terms of time, what we are going to have is going to be find velocity. So that will be like v of t. You'll be find v of t. So they will give you a question like this and ask you to find the what is the distance when the time is 3, or what is the velocity when the time is 3 seconds, how the velocity when the time is this thing. So what they ask you is that you have to know that when you differentiate distance in terms of time, you will get velocity, and when you differentiate velocity in terms of time, you will get acceleration. You get acceleration. So it's like you're going to do the second derivative, like what we did.
Oh,
Doing the second.
Francis,
Yes.
sorry, I received a call. Are we doing physics now?
Now, now it's going to science. Oh.
I know this is physics, I'm aware, but I don't know. So if you can just go 1 minute, use 1 minute to just go through for me.
Oh, all right. So we are not actually doing like how do you call it, physics, but this is typical applications of differentiation, right? One
Okay.
area of application in terms of speed and everything. So usually they will give you the expression in terms of they give us this expression in terms of distance, right? So when they give us distance and then they ask us to differentiate it or to find the speed. So if you are to find the speed from the distance equation, you just differentiate. When you differentiate, whatever you get will be the velocity or speed. So that will be the second derivative. So if you find the second derivative of this, that will be 9t squared minus 8t
That's
plus
derivative.
1. Yeah, this is the first derivative. So if you find the derivative of in terms of t, in terms of for distance, you are going to have v, which is velocity. Alright, but we know that this is the starting, so this is f, and but we know that in our mind we also know that this is our f prime. Okay, so now if you have the velocity and you are to find the acceleration, that's how they flow. So from distance to velocity to acceleration. So if we are to find the acceleration, you have the velocity, you have to get the velocity expression first. Then when you differentiate it, then whatever you have will be the acceleration. So acceleration in terms of t will be the second derivative of this. That will be, so the derivative of this velocity, so that will be 18 t minus 8. Yeah, so this is the acceleration expression.
So I think,
Then
Francis,
yes,
I think for me, for instance, I think I understand what you are doing, but we just like think that, if you could have used, but I mean, that is also not your field. So like a business example to demonstrate the same way, like when you do first derivative, you get velocity, second derivative, you get acceleration, like practically.
Business example asking. There's nothing like business example in this thing, so everything is basically as if it's physics and then this thing. There's nothing like business example. Or maybe I don't know. France, is it something like that? Do you have something like that?
yeah, you guys have this thing. Something
I know,
something diminishing return. You have it like that. We have a lot of.
Yes, sir. In economics, we did this differentiation in practically. So that's
Yeah,
why I was just
something diminishing return. So there's something over something. So I think they have cost over something. I mean, or profit over something like that. But the thing is that the thing is that
as you are doing. That's fine.
yeah, the thing is that there are so many, the concept stays the same, right? But you have to know. So when they give you this over this, when you differentiate, when you put the s, I mean whatever they give you, let's say if this is they say it's a cost, a cost over demand, what would I give? I forgot.
I don't know for you.
I'll look for
So I
practical
think
questions.
you are trying to do demand as against price.
Demand against price, right? Demand
Yeah,
against
so,
price. That one,
so demand is always is derived from price. So price is the independent variable.
yes, price is the independent variable. So like demand equals to, let's say, 3p minus 5, for example. So you can find the derivative, right, when the price is this. I mean, it tells you the rate at which when you change the price, how is it going to affect demand?
Yeah. Thank you.
Yeah, those kind of things. So, but the concepts remain the same across all fields.
Right.
Yeah.
Thank
All right.
you.
You're welcome. So there is some special case that you need to also have in mind. Even though this thing, what I did was very simple. I mean, straight. The equations are, straight. And then we need to also have in mind that the numerators will not always be, the powers, the indices will not always be like, so it can be something like this: x to the power half, or x to the power 3 over 2. So let's start with 3 over 2. X to the power 3 over 2. So if you want to differentiate this, so here is 1. So it's going to be like 1 times 3 over 2. X to the power, so it's going to be 3 over 2 minus 1. And that will give us 3 over 2 x to the power 1 over 2. You see that? So the concept is the same. So whatever number you have, just work with the number. Then you have access to that. And then you have to know that whenever the power is half, now we are referring to the square root. So square root of x is the same as x to the power 1 over 2. That's the square root. So if it is cubic root like this of x is the same as x to the power x to the power 1 over 3. So these are referring to the radical functions, right? They are also hidden if you have to know them. And so the power is not always going to be a whole number, but it can be. Yes.
Francis.
Yes.
My network was lagging again. I didn't get what you said.
So I'm saying that the power of the variable will not always be a whole number like 3, 4, 5, 6, but there could be fractions. So I gave an example that 3 over 2 is an example. And then when I differentiated this, I went here. Then I have 1. 1 is always here. So 1 times 3 over 2 multiplying. Then I do the subtraction for the top. Then when you do that, you finally have this. And I was saying that when you see the power to be half, it is the same as square root of x. When it is cubic root, meaning like it is power 1 over 3. That's for cubic root. These are square roots. How the square root connects to the variables.
So what it means is that the square root 2 is in front of the root.
Yes. Yeah, but we don't write it. When it's square root, we don't write it.
Right.
It's not in front, right? It's inside the elbow. How would I call it?
Yeah, inside the
All right.
Inside that thing, that's okay.
Yeah. Yeah, Charlie. Okay. Next, so we are going to deal with some function like that I want us to differentiate. So I have f of t equals to 3t cubed minus 2 root t. So we are going to, let's find f prime of t.
Okay.
So when you're done, you can mention it, then I'll write it.
I don't know. Okay, I got 9t squared. I feel like I can write it in another way. Minus t negative half.
Oh, all right. Rajesh,
But
do you also get the same?
I just feel like the half.
I'm not coming to do my own self. Oh.
Oh, all right.
My people are disturbing me. I'm coming.
Okay. You say you feel like you can.
Like I feel like I can do the half that is left. No? The half
Uh,
maybe I can do square root. So instead, like the t need to be square root of plus square root of t. I feel like that is not correct.
no, that's not correct.
Okay, I'm just trying to see if I can simplify it further.
Yeah, you can write it better. I will help you.
Okay.
Let's give a minute to Brajeram and see.
Wait. Let me see something. It's actually minus 3 over 2. The t is raised to the power minus 3 over 2.
Minus 3 over 2. All right.
Because this would be 4. This would go here. Yeah, minus 3 over 2.
Hello, Francis. My
Yeah,
mic is mute. I said 9t squared minus t raised to the power 1 over 2.
90 squared minus 2 to the power 1 over 2. All right.
Write it.
Yeah, I'm now
Solve
coming
it.
to solve it. So let's solve it together. So this thing could be written as, I'm trying to remove the square root first. T cube minus 2 t to the power half. Yeah. Now if you proceed, then it's like 9. So this will be 3 times 3 times t squared minus into brackets 2 times half this thing t to the power half minus 1 at the top, and that will give us 9 t squared here minus, this is 2 times this will cancel to be 1, so that will be t to the power, if you do this, 1 minus 2
That will be negative
will
half.
be negative
Oh.
half.
The first one I did was
When I was mentioning, I didn't mention the negative.
Oh, all right. Okay, so now rewriting this, right, is negative half. So whenever the index, if I give you a to the power negative 1, because of the negative as the index is the, I mean it's a power, so it's the same as 1 over a, just a reciprocal, because because of the
Yeah.
negatives, you just reciprocate it. That's what indexes do when the indexes are negative. So in this
Yeah.
case, it would have been 9t squared minus
This
1 over
one.
t to the power half, right?
Yeah, 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 yeah.
Which is the same as
Don't come back to my
9t
senses.
squared minus 1 over root t. Are we good with this one?
Yeah.
Alright. Boss Nick, is it okay?
Yeah, so it's okay. Yeah, it's okay.
Yeah. Do you understand how I change it? But this answer was correct though. The reason I'm changing it is
Yes.
because you might meet it in a question, but you yourself, you could stop at that level. But then what if you meet it somewhere, you have to change it from that aspect? Alright. So talking about that, we are going to differentiate something to actually see how we understand this. This is very, very important. Let me write it down before I'll be cleaning. So the thing
Another
is, yes, 4t squared minus 12 plus 4 over t squared. Yep. So let's differentiate that.
okay. I don't know whether I'm correct or not. Though.
So
I
let's
got
have it.
8t
So f prime of t equal to 8t
minus 8t negative raised to the power negative 3.
negative 3. Alright. Let's wait for Brother Jerome.
Okay, I think that I am correct.
Brother Jerome, are you done?
Correct.
Maybe network issues again. I want to at least be on the product before we end.
Hello.
Yes.
Yeah. Hello. My network. Oh.
Yeah, we can hear you.
Yeah, I think
Uh,
the first one is the HT. Then the other one I had it. I've simplified it. So I had H all over T cube. I don't know whether that is correct or
Yeah, it's the same thing.
I think it's also correct. Yeah.
Yeah, it's the same thing. And actually, it's correct. It's correct. The both are correct. All right. Now we are going. So these are the simple differentiation. I want to really enter product rule at least one of the rules before we close. So I want to do the product rule. We are going to first do our product rule first. So how does the product rule concept come in? So this is where you are seeing two functions multiplying or two expressions that are multiplying each other.
Francis.
Yes,
Francis.
yes.
I think for the sake of David, for the sake of David, then resolve it. And so that when he's watching the video, he can follow.
Oh, all right, all right. So where are we? We were here. All right.
No, I just
So
want you to solve this particular one for him.
all right. So to find the f prime of t will be equal to this 4 times 2 t to the power 2 minus 1 minus 12. So this is a constant. So for that constant here is 0. So we focus on plus. So I can rewrite this thing actually. So this particular one can be rewritten as 4t to the power negative 2. So in that manner, that will be plus into bracket 4 times negative 2 from the top, t to the power negative 2 minus 1. So we have 8t minus, because 4 times negative 2 will be negative 8 t to the power negative 3. Negative 3. And when the index is negative, it means that variable should be reciprocated. So minus 8 over t to the power 3, which are all valid. All right. So we need to now go to the next concept in differentiation called the product rule. So for product rule, what happens is that you'll be seeing two functions multiplying or two expressions in terms of the independent variable multiplying. Right. So we'll start with simple example and expand it on more complex example so that you have an idea. So when you look at the function at one, they will ask you, okay, then you know that, oh, for this one there is product rule. Oh, for this one there is no product rule. So an example, let's say I have f of x to be equal to 2x 1, that is multiplying 5s to the power 4 minus 1. So this is what we are to differentiate. So what people will do is that to use the 2s to expand this, like 2s to expand this, and then you will be doing 2s times this, that will be 10 to the power s to the power 5 minus 2x. Then you differentiate this to give 50x to the power 4 minus 2, right? This answer is valid. But we are going to learn the product rule, because what they will actually give you will not be as simple as what we are seeing here. So we are going to use these simple questions to actually know how to use the product rule. So to do the product rule, I call it do me, I do you. So there are two functions of multiplying. So this is one expression of functions multiplying another expression of another function. That's also an expression. Okay. So let me call this one function 1 and function 2. So what you do is that to find the derivative when it comes to the product rule, is that you differentiate function 1. So you find the f prime of 1, function 1. You use it to multiply function 2, the undifferentiated function 2, plus, now it's the turn of function 2 to be differentiated. So you keep function 1, then you differentiate function 2. This will be the answer. So it's like do me, I do you. First, function 1 gets differentiated, you use it to multiply the original function 2. So you keep function 2 and differentiate function 1. Plus, now you keep function 1, then you differentiate function 2. Then you proceed from here using your normal math to get your product rule. So that's what we call the product rule. So you keep one, use differentiate the other one. That's why I call it do me, I do you. Someone does it first, the other one also does it in the other way, after in the other round, meaning after the plus. So in this particular case, so our function 1 is this guy, so I will differentiate 2x. If I differentiate 2x, I'll be having 2. Then I'll keep function 2, which is 5x to the power 4 minus 1. Now we keep it. Plus, now we are going to keep function 1. Which, yes?
Please, when you're done, take it from me again then.
Alright. So now we keep function 1, then we differentiate function 2. We differentiate function 2 until you have 8.
20
Yes.
20, yes.
Yeah, it's 20 x to the power 3. Actually, at this stage, you are done. If you can further simplify, then you go ahead and do it. So this one, we just expand this to get your, so this one will be 10 x to the power 4 minus 2 plus 40 x to the power 4. Then when you do that, you will be having 50
x to the power 4 minus
x to the power 4.
Yeah, it's the same
2.
answer.
Yeah, it's the same answer that we got first.
Yeah.
Alright. So, Rajaram, I'm trying to go over it again. Please, are you there?
Yeah.
Okay.
Yeah, I'm
alright.
now.
So I'm saying that.
Okay. You can start now.
Alright. So I'm saying that for product rule, you'll be seeing two functions multiplying. So in this case, it's clear that we are seeing two functions that are clearly multiplying each other. They are all inside the f of s, but these expressions are multiplying each other. And if you look at it, this is, you label it function 1 and function 2. So for the product rule, for the differential of whatever you are doing, it goes like this. You keep one function, the order doesn't matter because it's plus. So you keep one function. Me, I'm deciding to keep function 2 first, and then differentiate function 1. So you differentiate one, you use it to multiply the original of the other. Plus, then when you do that, then you change the row in the next stage. I mean, after the plus, you change the row. Then you keep the other one. Then you differentiate the other one to multiply each other. So they all come together to form this thing. So, please, is this one clear though?
It's clear. I just want to ask something.
Yeah, it's clear.
All right. What's the question? Yeah.
So the same question, can it be 2x divided by 5x raised to the power 4 minus 1, and we'll still use the product rule by reciprocating?
What do you say? Are you asking another question?
Yes.
Say what?
2x divided by 5x 4 raised to the power 4 minus 1. And I'm just saying, we can use the product rule for this too, right?
No. This one we'll do quotient rule. Right now we are doing product.
I was thinking you can just reciprocate this, like just 2x that you multiplied by.
No.
Okay.
This is quotient. So what we are doing here is product, right? This is quotient. We also have quotient rule that we'll do later on.
Okay, sure.
Yeah. So when you see the functions like this, then you know that, oh, this one they are multiplying, so we have to use quotient rule, product rule. If they are dividing, we use quotient rule. If there's another one called the chain rule, So let's first take it one by one. So Brother Jerome, I was here and I was saying that yeah, this is the rule. So we just apply that concept here on this example. So now when I did that, I realized that I kept my function 2. I differentiated function 1, that is just 2 plus 2x multiplying 20x cubed. Then I just continue with the simple math to simplify. But you don't, should I go over again?
I'm fine.
All right. See this one. If I had given a function like this, f of x is equal to 2 multiplying 5x power 4 minus 1. Please, this one is a constant. It's not a function. I mean, it's not a function expression. You see, it's 2x. But a function should also contain, if it's a separate multiplying, make sure that whatever is multiplying is also like expressed in terms of the independent variable. Right? Okay. So you cannot be using product rule here. This one, you cannot use product rule. You just do normal expression because this one is just a constant. So I want you to clearly see the difference. This one is a constant multiplying this, so it's not, you are not going to use a product rule. You just do your normal expansion and then you go ahead. But is that okay?
Yes, please.
So in the same way, if I had done 2t multiplying 5x to the power 4 minus 1, the independent variable is x, not t. T in this case is a constant because the only variable that we have, the variable, so we focus on what is the variable. The variable is x. The variable is x. T here, even though it's a symbol, is not a variable because that's not inside the independent variable. Independent variable is our x, not t.
Hello,
so you
Francis.
cannot use, yes.
Francis.
Yes.
Hello, Francis.
Can you
So
hear
what
me?
if
Yes.
we have 3 terms? Are we going to use the same rule for it, or
Okay, if
can
you
you hear
have
me?
3,
Like, let's say if you
yeah.
have 3 functions, yeah, are we using the same rule? Like you differentiate the first one and use to multiply the other 2. Or can you hear me?
Yeah, I can hear you. So for 3 expressions, right? So what happened is that you do
Hello?
Yes, can you hear me?
I can hear you. I think your question is clear.
Rajaram, can you hear
Okay.
us?
Yeah, I can hear you now.
Yeah, so you do it in pairs. You take the first 2, you do it right. Whatever result you get, use it again the third one. But
Yes, I
it's
can hear you
rare.
now. So you continue.
We didn't the network. But mostly for product rule, there's possible to have the 3, but you have to do it in pair. Take the first 2 first, then use the result of that to do it with the third one. But that one, I think they will give you just something simple. I mean, to be able to handle fast. But mostly it's these 2 functions multiplying. I mean, mostly. I think Rajaram still lost us. We still lost him for some time. So now the next one is an example. Yeah, the next one is an example that you will try on the product rule. Let me write it before I start screening. So I have f of x equals to 2x to the power 4 minus 3x plus 5 multiplying s squared x squared minus root x plus 2 over x. So we have to find the f prime of x.
Okay.
Yo, go. Wata dol mi ma pe. Hmm. Hmm. Okay, okay. Arigato do ma.
Francis,
Egba tezi. Yes, yes.
this, this is what I got. I I got. I don't know whether I should simplify further, but
No, no, no. You don't have to
I
necessarily
got
see. You have what?
8s cube, 8s
Mm-hmm.
cube
Mm-hmm.
minus 3, that is
Mm-hmm.
in one bracket,
All right.
multiplying
Mm-hmm.
x squared minus x half plus 2 over x,
Right.
then plus 2x minus half x raised to the power negative half minus 2x raised to the power negative 2,
All right.
multiplying 2x raised to the power 4 minus 3x plus 5.
Yeah, that's correct. That's very correct. Brother Jerome, I mean, Jerome could express it in a different way. Brother Jerome, can you hear me?
Hello. You said, yeah, you said,
Yeah. Are you done?
I just finished with the first step. Oh.
Oh, all right.
Is that what you're asking for? Or the final answer?
But it's the final answer, though. But you don't have to. Um, how will I say this word?
You have to simplify further.
Yes. You don't have to simplify further.
Yeah, so I'm here to do the multiplication.
No, no. Like, what do you have right now?
Right now I have I'm coming, I'm really confused.
So, Jerome, what he's
When
saying is that after
I have 8x cube.
Yes.
Can you hear me? I have 8x cube minus 3 multiplying x squared minus x raised to the power half plus x raised to the power negative 2. Then
Uh,
plus, so I'm here to multiply that bracket, yeah. Then
no,
plus,
no, no, you don't have to. No, the second bracket. You say the last one minus s to the power half plus what?
I'm just trying to rewrite the root x and then the 2 over x.
And yeah, and the 2 over x, what do you have when you are rewriting it?
The 2 over x. That is x to the power negative 2, right?
No, it's
No.
2x negative, yeah, 2x to the power negative 1.
Yeah, 2x to the power negative 1. I have different thing in my book, different thing. Oh my goodness. I have different thing, I mentioned different thing. Okay, so I'm here to multiply that bracket. So if you multiply, that will give you what Nick mentioned, right?
No. That's what he mentioned. You don't have to go and multiply further. Like proceed with the plus. I
We
want
are
to
not
know
supposed
the
to
other
multiply
side.
further.
No.
Why are we not supposed to?
Because
So you're
that's the
supposed
Okay.
to,
answer. Simplify
yeah,
further
you are
is just
supposed
your
Okay,
own.
then plus, then we now have.
uh,
So if that is the case, then I will just have to maintain the first bracket, which is the 2x to the power 4 minus 3x plus 5. Then I have to differentiate the second one, which will
Yes.
give you 2x
Mm.
and then minus half x to the power negative half,
uh,
then minus 2. Is that it? I'm coming.
No, it's not minus 2.
This time,
Do
this
it.
here. Then it's what?
Do it
minus 2 of
again.
something.
Yeah, minus 2, then x raised to the power negative 2.
Yeah.
Yes. So that's the same thing that you mentioned.
Yes.
So that's the answer.
Okay. Yeah, I was trying to continue.
Ah, that one is like
Yeah.
your own. I mean,
It's giving me a long something. I was like,
no,
in
no,
my
no.
book too.
You don't need to. So when you differentiate like that, sometimes they will give you the value for x, and you just plug in the value for s to get the exact value of f of s that they want.
Oh, okay.
Yeah. So the one that we'll try on our own is x to the power 4 minus 3s squared plus 2x multiplying x to the power 3 minus 2x plus 3. So find the value of find y prime at x equals to 0. So we
Oh,
have to
okay.
find y
This is a
prime
new
at x.
question.
Yeah, this is a new question.
So we
The
have to
one you
differentiate. Then we put 0 into everywhere we see x.
yes. So the
Okay.
answer you can say it in the group.
I'm coming. Let me copy the question first.
All right. So this is just a tryout. So you try it, then you give me the answer in the group. Then I'll confirm.
But this thing that is for if they give us assignment, can't we use AI and solve this thing and put it on paper and go and submit?
Yeah, AI messes up a lot when it comes to math.
Sir,
Yeah, you'll be lucky.
I'll take a picture of the question to be put
Well,
Especially
on
if it's
site.
very, especially if
sir,
it's very, especially if it's very complex.
I mean, this one can we do it
So,
because
so,
it's
so
no.
the thing is, yeah. So the thing is that I mean, because you know the thing, if you give it to AI, then
I
you know
think
that
I'm done now.
hey, you are done. What do you have? What's the answer?
I have 2 on the first bracket, so
Oh
this
no,
whole
I'm
thing
looking
is
for y prime at s equals to 0.
yes. So I've differentiated, I'm putting 0 into wherever I see x. Is that not it?
Yes.
Yes, so that's what I'm saying.
Yeah, so I just want the final answer. The answer is just one thing. So I want to know
Yeah,
the
yeah.
final.
Please, I'm just gonna. Um, okay. I get what you mean. This thing all will be zero. This thing all will be zero. A minus two. Okay. So it is two here plus
My calculator is not working. Okay.
two here multiplied by three. And this is
This
minus
thing
two.
won't be zero now. So this will be 2 here. Two
Yeah,
plus
so that
6.
is four. I have four.
Right, you know what do you have?
That's it.
Yeah.
And it will be 6 minus 2.
Yeah.
Ah. Am I the one who did it? This is 2x. Oh,
Yes.
Which one?
one. It's 2x. Oh.
And so when it be, won't it be
When you
2?
differentiate it to be two.
One times
Yes.
2 is 2, and then 1
I
minus
mean,
1.
check your thing away. Remember that you are keeping this one in the second round or in the first round somewhere.
Yeah, so
Now, when you
we
put
keep it in the second round.
if you put it in the second round, if you put zero inside, everything here will be zero. So whatever is multiplied is
Exactly.
also zero.
Yes. Yeah, it's the same
Exactly.
thing.
Exactly. Ah, I get what you are saying. I get what you are saying. So it will be six. The answer will be six.
Yes, not 6 minus 2.
Because zero
Right?
multiplies zero minus two
I
is
still
zero.
don't get it.
No, Jerome. So we had zero. Then multiply zero minus two is going to be zero, non-negative two.
Ah, Jesus.
Right, Jerome, have
All
you seen
right.
it?
So the whole of this is 0. Yeah, so
Yes.
the second one, the whole of 0
Yes.
multiplied by 3x squared minus 2. Okay.
Yes.
Yes. So
And
it's
that's why
eight.
I like writing the thing, oh, because if sometimes if you want to do those things, you score 0, knowing very well that you know the answer. Now, so I did. I didn't get A1 in elective maths. So now, since then, I was like, no, everything I have to write, because if like I was solving it manually, I would have noticed that.
All right. Let's meet tomorrow to continue with the
Thank
quotient
you.
rule.
Thank you.
So you are still
Thank
on
you
the
very much.
differentiation.
Yeah, differentiation, we need to really do it. So it's that we are doing calculus entirely.
Oh, okay.